Okay, today I'll be explaining two sections from chapter 16, the first lesson, the electric charge, and the second lesson, electric force. So let's start first of all with section 1, 16.1, electric charge. So here we have a negative charge, which we could call it negative Q. And then here we have a positive charge, which we call it positive Q. And then here this line, this arrow is called the electric field vector, and then here it's called the electric field line. So these are like symbols that you may know. Now, atoms have three subatomic particles: the proton, electron, and neutron. Now, the proton has a positive charge, electron has a negative charge, but the neutron doesn't because it's neutral. Okay, because positive and negative, so they cancel each other. So then for the proton, it's 1.6, it's positive 1.6 times 10 to the power of negative 19 coulomb, and for the electron, it's negative 1.6 times 10 to the power of negative 19 coulomb. Now the like charges. Now we have the like charges repel and the unlike charges attract. So as you can see here, the positive they repel, and the negative they also repel. But then we have the positive negative because they are unlike charges, they attract. Now examples of creating static electrical charges. Now rubbing a balloon against your hair or paint spray onto targeted object. Now electric charges are also best created in dry days. Now let's move on to the properties of electric charges. Now first of all, there are two types of electric charges: the like, which repel, and the unlike, which attract. Second, electric charge is conserved. Losing two electrons creates positive 2q. Gaining 2 electrons creates negative 2q. Now electric charge cannot be created nor destroyed. Now let's move to the third property. Electric charge is quantized. The total amount of charge is always a whole integer multiplied by 1.6 times 10 to the power of negative 19 coulomb. So this is the Q. So Q equals to equals to N times 1.6 times 10 to the power of negative 19. Okay, so this is the Q, this is the N, this is the E. So the E is the 1.6 times 10 to the power of negative 19 coulomb. Now we have types of materials. First, we have the conductors. Conductors allow the charge to move freely, for example, like metals. Insulators, they don't allow charges to move freely, for example, like wood or glass. Semiconductors conduct electric current between conductor and insulator. Here, this is a chip. And then we have the superconductors conduct electric current without heating. Now, ways of charging. We have first conduction. Now, conduction is the transfer of charges by direct contact. For example, rubbing a balloon against your hair. So as you can see here, the first part, when you rub a balloon against your hair, the hair has positive charges while the balloon has negative charges. So they will attract because they have opposite charges. Now, if you rub a balloon against if you rub two balloons against each other, they both have negative charges, so they would repel because they are both like charges. Now the second way is the induction. Now induction is the rearrangement of charges due to another close charge with no direct contact, not like the conduction, which is with direct contact. So here it's without direct contact. Now example is rubber rod near metal sphere. So as you can see here, the first thing here, the electrons move away from the rod. Okay, so they move away from the rod, they come to this side, to the right side of the sphere, and the charge on the sphere becomes redistributed. Then if the sphere is grounded, some of the electrons, they travel through the wire to the ground. Then here, when this wire is removed, okay, the sphere has an excess of positive charge, so there are more positive charges than the negative charges. Now here the electrons become equally distributed on the surface of the sphere when the rod is removed. Now the third way is polarization, which is the rearrangement of charges due to another close charge with no direct contact also. Okay, so example is between charged object and insulator. So as you can see here, we have a negatively charged object and the insulator, which has like both the positive and negative charges. So here the positive and negative charges will be rearranged. Okay, and the same here it's different, the opposite. Here we have the positively charged object, and here we have a sphere that contains both the negative charges and the positive charges, so it will become also rearranged. But here it's oppositely, as you can see, so it's opposite. So if this is the charged object is negative, the positive will go to the left side and the negative will go to the right side. And here, if the charged object is positive, the negative charges will go to the left side and the positive charges will go to the right side. So that's it for section 1. Now we move on to section 2, the electrical or the electric force. Now the closer the two charges are, the greater the force on them. Now what is the relationship between distance, charge, and electric force? Now the more the distance, the less the charge and less the electric force. So as you can see here, we have two charges. So let's say the distance between them is 5 meters, which is the r, and it's the distance. So it would be the less the charge and the less the electric force. Now here, the less the distance, the more the charge and the more the electric force. So as you can see here, we have also the two charges, but the distance here is less than the one here. So let's say it's 2 meters. So here the charge is more and the electric force is also more. Now Coulomb found that the electric force between two charges is directly proportional to the product of the two charges. So it is directly proportional to the charges. Now Coulomb also found that the electric force is inversely proportional of the distance between the charges. So it is inversely proportional to the. Now Coulomb's law is the electric force equals to the Kc, which is Coulomb's constant, which equals to 9 times 10 to the power of 9 Newton dot meter square per Coulomb square. And we always know that the unit for force is Newton. So Q1, Q2 over R squared, which is the distance. So this is the distance, this is the charges, and this is Coulomb's constant, and this is the electric force. Now, if one charge is doubled, the electric force likewise doubles. And if both charges are doubled, the electric force increases by a factor of 4. Now, when the distance between two charges is halved, the force between them increases by a factor of 4. So here we have two charges, Q1 and Q2. So what would they repel or attract? They are different charges or they are unlike charges, so they would attract. So this will be called F of 1 on 2, and here this will be called F of 2 on 1. Okay? Now here we have here, as you can see, the positive and the negative. So they would attract because they're unlike charges. So this would be called F3 on 1 and F1 on 3. Okay? Here they would also attract. It would be called F1 on 2, F2 on 1. Now here they are like charges, so they will repel. So first of all, measure this with a ruler so it could be in a straight line. So they would repel like that. So this will be called F2 on 3, and here 3 on 2. Okay? Now, what is electric force? Now, electric force is when the two charges near one another exert force on also one another. Now, Coulomb's law states that the electric force is directly proportional to the magnitude of each charge and inversely proportional to the square of the distance between them. So this is the law that we just explained. Q1 over R squared, and you said that the unit is Newton. Okay, now let's start with a practice. Now, a balloon rubbed against denim gains a charge of -8 microcoulomb. What is the electric force between the balloon and the denim when the two are separated by a distance of 5 centimeters? Okay, so let's take out first the givens. So we have -8 -8 microcoulomb. So this would be both the Q1 and the Q2. So the Q1 would be -8 microcoulomb and the Q2 would be +8 microcoulomb. So we remember that micro is times 10 to the power of -6. So it's going to be -8, converting to -6 coulomb, and here it would be positive coulomb. Okay, and the R is 5 centimeters, so 5 times 10 to the power of -2 meters. So I apply the formula Kc, and we know that Also Kc, we said that it's 9 times 10 to the power of 9 Newton dot meter square per column squared. So Kc, Q1, Q2 over R squared. So remember, when you put the Q1 and Q2, you ignore the negatives. So absolute value. Okay? So the Kc, 9 times 10 to the power of 9 times the Q1. So we could just do 8 times to make it faster, squared, over the R squared, which is the 5 times 10 to the power of negative 2 squared. So the F electron would be 230.4 Newton. Don't forget the unit. Now to the second question. Two identical conducting spheres are placed with their centers 0.3 meters apart. One is given a charge of positive 12 times 10 to the power of negative 9 column, and the other is given a charge of negative 18 times 10 to the power of negative 9 column. A. Find the electric force exerted on one sphere by the other. B. The spheres are connected by a conducting wire. After equilibrium has occurred, find the electric force between the two spheres. Let's start with A. And the given for all of them, for both A and B, is the R, which is 0.3 meters. Now let's start with A. So A, the given for it is, the Q1 and the Q2. Okay, so the Q1 is 12 times 10 to the power of negative 9 column, and the other one is the Q2, which is negative 18 times 10 to the power of negative 9 column. Okay, and this is the formula. So let's apply. So remember, the Kc is 9 times 10 to the power of negative positive 9 Newton dot meter squared per column squared. So 9 times 10 to the power of 9 times 12 times 10 to the power of negative 9. We ignore the negative for the number here, not for the power. Times, so ignore the negative, so it's going to be positive 18 times 10 to the power of negative 9. And then R squared, which is 0.3 squared. So the answer would be F electron, the electric force would be 2.16 times 10 to the power of negative 5 Newton. So would it be attractive or repulsive? So here the charges are unlike, so they would attract. So it's gonna be attractive. Now let's do B. So B, they said the spheres are connected by conducting wire. After equilibrium has occurred, find the electric force between the two spheres. So, first of all, we have two spheres. So let's draw the two spheres. So this would be 12 times 10 to the power of negative 9 column, and here negative 18 times 10 to the power of 9 column. So we said that it would be attractive. So this is Q1 and this is Q2, and we said that the distance between them, the R, is 0.3 meters. Okay, so now we subtract it. Okay, we subtract the 12 times 10 to the power of the Q1 with the Q2. So it would be negative 6 times 10 to the power of negative 9 column. Okay, now so this would be helpful for the B part of the question. So let's draw here. So here it would be, we divide it by 2. So here we divide this by 2, so it will be negative 3 times 10 to the power of negative 9 column, and here it will also be negative 3 times 10 to the power of negative 9 column. And here we would know that this is repulsive because they both, so it would be repulsive. So now we have, this is the Q1 and this is the Q2. So now we could just apply the formula and we'll use the distance, which is 0.3 meters. So times, so ignore the negative, so just say 3 times 10 to the power of negative 9 squared over 0.3 squared. So the electric force would be 9 times 10 to the power of negative 7 Newton, and we said that it is repulsive. Okay. Now we move on to question 3. Now, two electrostatic point charges of 60 microcoulomb and 50 microcoulomb exert a repulsive force on each other of 175 Newton. What is the distance between the two charges? So we have the givens. Let's take out the givens. So Q1, which is 60 microcoulomb, Q2, which is 50, positive 50, they're both positive 50 microcoulomb. So we'll convert this, so it will be 60 times 10 to the power of negative 6 coulomb, and here 50 times 10 to the power of negative 6 coulomb. Okay, and then we also have the electric force is 175 Newton. Now let's here change the equation a bit so we could find out the distance. So this is the equation. Now let's cross multiply. Okay. The electric force times the distance, and then over the r squared. So then simply it would mean that r equals to radical, okay, Q1 Q2 over r squared. So now over okay, so 9 times 10 to the power of 9, and then Q1 60 times 10 to the power of negative 6, and then 50 times okay, so 50 times 10 to the power of negative 6 over 175. So the R would be 0.392 meters. Okay, so that would be the answer. Now let's move on to superposition. Now here we have the negative and the positive. They are So first of all, let's note the steps. The first step is to draw the forces. Second, to find each force using Coulomb's law. The third is to find the component of x and y, and then fourth is to add x component, which is the fx, and the y component, which is the fy. And then we find the final step is to find the f net, which equals to radical, okay, fx squared plus fy squared. And then we find the angle also, which is going to be in tan inverse over 5y over fx. Fy over fx. Now, so here we have a negative charge. So here it's drawn already. So we finished step 1. Let's consider it done. So then we have here a negative charge and a positive charge. So they would attract. So this would be called F2, 1, 3, and this would be F3, 2. Here they would also attract. So F2, 1, F1, 2. So here they would repel. So F1, 3, F3, 1. Okay, now let's find each force. Now, so F3, 2, which is this, so they're the same. So F3, 2 and F2, 3 equals to F2, 3 equals to, so this is the rule. So 9 times 10 to the power of 9 times, or you could just write it immediately, times, here this is the Q2, which is negative 2, so it would be converted to negative 2 times 10 to the power of negative 9 column. So here we would ignore the negative, so it will be 10 times 2 times 10 to the power of negative 9, and then times here the Q3, which is will be converted to 5 times 10 to the power of negative 9. So 5 times 10 to the power of negative 9 over the r, which is going to be here the 4. So 4 squared. Now before continuing, let's move on to find out, first of all, before everything, let's find out here the distance here. So here we have 4 and 3. So we'll use the Pythagorean theorem. Okay, let's just go directly and do it, which is going to be radical 3 squared plus 4 squared. So C would be 5. So this is 5 meters. So here the answer would be 5.6 times 10 to the power of negative 9 Newton. And it's attractive because the two charges are unlike. They're negative and positive. Now, the F31 equals to the F13. So 9 times 10 to the power of 9 times, here it will be converted 6 times 10 to the power of negative 9 column, which is the Q1, so times the Q1, which is 6 times 10 to the power of negative 9, times the Q3, which is 5 times 10 to the power of negative 9, over 5 squared. Because as you can see here, the F13 and F31, so it's on this line, so it's the 5 meters. So the answer would be 1.08 times 10 to the power of negative 8 Newton, and it's repulsive because they are both like charges, which is they're both positive charges. And then the last one, the final one, which is F21 equals to the F12 equals to 9 times 10 to the power of 9 times 1, which is 6 times 10 to the power of negative 9, and then also times the F2, which is, we ignore the negative, 2 times 10 to the power of negative 9 over, so it's here F2 and F1, which is 3 meters. So it's going to be 3 squared. So the answer would be 1.2 times 10 to the power of negative 8 Newton, and it's attractive because they are both unlike charges. Now, so this is the second step, so we are done from the second step. Now let's find the component of x and y. So to do that, let's draw. So we would take from here. Okay, so we take this and make it an x and y axis. So it will be it will be like that, and then like that. F32 and F31. Now to find the angle, okay, we'll use tan. Remember this, okay? So we would do that. So here's the 4, here's the 3, and here's the angle. So tan inverse 1/3/4. So the angle is 37 degrees. So here it will go to this side and then go to here. So it will go like that. It would be sine, and then when it goes here, it will be cosine. So here it would be F31, because here it has both components of the x and y, but here it only has the x component. So here it would be, so let's just, here it would be F31 sine 37, F31 sine 37 degree, and here it would be F31 cosine 37 degree. So the answer here would be 8.6 times 10 to the power of negative 9 Newton, and then here it would be 5 times 10 to the power of negative 9 Newton, and then we know the F32. Okay, so now let's find the x and the y components. So let's find the x and y components. So let's start with the F32, which is the 5 times 10 to the power of negative 9 and then the y, because it's lying here on the x-axis, so it would be 0. So here, this is 6.5. So now let's find the x and y components. Now for the F32, it is 5.6 times 10 to the power of negative 9. Now because it's lying on the x-axis, the y would be 0. And then we have the F31, which is 8.6 from here, 8.6 times 10 negative 9, and then it would be 6.5, which is here, which is the y component, which is this 6.5 times 10 to the power of negative 9. Okay, so now let's find the, so we finished the third step, which is finding the components. So now let's find the, we'll move on to the fourth step, which is adding the x component to the y component. So adding this with this would be 3 times 10 to the power of negative 9 Newton Fx, and this would be, if we added 0 plus 6.5 times 10 to the power of negative 9, so it's just going to be 6.5 times 10 to the power of negative 9, so this is the Fy. So now let's find, so we finished the fourth step, and we move on to the fifth step, which is finding the F net and the angle. Fx squared plus Fy squared. 3 times 10 to the power of negative 9 squared plus 6.5 times. So now we find the F net. 3 times 10 to the power of negative 9 squared plus the Fy, which is 6.5 times 10 to the power of negative 9 squared. So the F net would be 7.15 times 10 to the power of negative 9 Newton. And let's find the angle, which is tan inverse Fy over Fx so tan would be 6.5 times, which is this here, times 10 to the power of negative 9 over here. So 6.5, this one and this one, over 3 times 10 to the power of negative 9. So the answer would be 65.2 degrees. Okay, that's it for this question. This is like finding the net charge on Q3. Okay, so on Q3. And then you can do it for the rest of them. Now let's move on to the second part of the questions in this lesson, which is when it's at equilibrium. So here we have Q1, which is 5 microcoulomb, and here Q3, and then Q2, which the Q2 is 3 microcoulomb, and then the distance here is 10 meters. Okay, so now let's start answering. So it's gonna be F. So first of all, this would be attractive. They will attract to each other because they are opposites, and also the same as well here. So this would be F23, F32, F31, F13. So we'll take the F31, this one equals to the F32. Okay, so this would be the X, and this would be the 10 minus X. So here, or let's call it R better. R1, which is the 10 minus R, we'll call it 10 minus R, and this is the R2, which we'll call it R. So now F31 equals to F32. So KC Q3 Q1 over R1 squared equals to KC Q3 Q2 over R2 to the power of 2. Okay, so we'll cancel out the KC's and the Q1 and the Q2. So what will be left out is we would cancel out KC the KC and the Q3 and the Q3. So what would be left out is Q1 over R1 squared and the Q2 over the R2 squared. Okay, so now, the Q1, this would be converted to 5 times 10 to the power of negative 6 column, and this would be converted to 3 times 10 to the power of negative 6 column. So here the Q1, which is going to be 5 times 10 to the power of negative 6 radical over the 10 minus R d1 squared equals to the Q2, which is 3 times 10 to the power of negative 6 radical over the R12 squared. Sorry, R2 squared. So here it would be 2.24 times 10 to the power of negative 3 over 10 minus R so we could cancel out the here, this cancels out, so we'd find the radical and this would be cancelled out. So here it would be just R, and here it would be 1.73 times 10 to the power of negative 3. So cross multiply, so it would be 10 minus R times 1.73 times 10 to the power of negative 3 equals to R times 2.24 times 10 to the power of negative 3. So we multiply. So we multiply 10 by 1.73. It would be so 19.3 times 10 to the power of negative 3 minus 1.73 times 10 to the power of negative 3 R equals to 2.24 times 10 to the power of negative 3 R. So we're going to take this to the other side and add it. (2.24) times 10 to the power of negative 3 R plus, because here it's minus, 1.73 times 10 to the power of negative 3 R. So the answer would be 3.9 times 10 to the power of negative 3 R. So 3.9 so R would be 4.43 meters, and that's the answer. And that's it for this section. And thank you. Hope you understand.